exception manually. And what is the purpose of this keyword throws means? I recorded up.
Now only it started recording.
Okay. Someone recorded. Okay, no problem. And then throws. What is the purpose of this keyword throws? So if you define any method, that method may cause exception means you have to use this keyword throws. So by using this, in a function declaration, you can use this throws bar. So by using this keyword, you are instructing this function may throws this type of exception. For this type of exception, there is no error handling mechanism in function definition. So those who are all calling that function, you are only the responsible person to handle that exception. So by using this throws keyword, what I am telling, so this throws is used in function declaration. So by using this, what I am instructing to the user means, so this function may throw this type of exception, and there is no error handling mechanism within function definition. So those who are all calling this function, you have to handle. So like that, I am giving an information to user by using this keyword throws bar. So now you got idea about this 5 keywords, ma? Somewhat idea about this 5 keywords. Say yes or no, ma? Say yes or no, pa?
Yes, ma'am.
Yes, ma'am.
Okay, thank you, ma.
Yes, ma'am.
Try block is used for if any statement that may cause exception means you can write those statements within try block. Okay, va? And then the catch block is used to handle the exception. Okay, va? And then finally block. So whether exception is there or not there, this finally block is executed before the return statement. And then throw statement is used to manually throw the exception, and throws is used to give an instruction to user that these functions are all made these type of exception you have to handle. Okay, va? And then this is the syntax. Try catch. The finally should be at the end of the catch block, and you can also write finally alone without a catch. You can also only finally block, right? After that, finally. And then next, checked exception and unchecked exception. So what is mean by checked exception? Some statement, a compiler itself, it can identify this may cause exception. So it won't allow you to write without a try catch block. Those statement cannot be written without try catch block. So if you written without a try catch block, then compiler itself, it will give an instruction. So this statement and all may cause exception during runtime. So you should write within try catch block. So that type of exceptions are all called checked exception. Okay, that type of checked exception, unchecked exception, some statement cannot be identified by the compiler. Okay, so some statement cannot be identified by the compiler whether the statement may cause exception or may not cause exception. That cannot be identified by the compiler. So that type of exceptions are all called unchecked exception. Okay, and then if you have a written exception handling means that is the statement are written within try catch block means that is handled by catch block. If you are not written the statement which may cause exception, that statement are not written within try catch block, that are handled by JVM itself. So if JVM handle that exception means it given instruction to us, this is the exception, but the program is terminated abnormally. If you are handle the exception means the program won't be terminated abnormally, but if JVM handle that exception, it will give an information, these are the exceptions, but the program is terminated abnormally. And then multi-catch, so single try block can have more than one catch block. And then nested try statement. So try block within another try block, that is called a nested try. And then in one function, the function call is written within one try block, and the definition also, if I have one try catch block means that is also called a nested try block. The function call is written within try catch block, and then within the definition also, if I am having one try catch block means that is also considered as nested try block. So if there is no corresponding catch block in the inner try block, then that is catched by the outer try block, outer catch block. And then a throw. So this is throw is used to throw the exception manually. And then okay, so these are all the example for unchecked exception. So the statement should be unchecked exception. Compiler won't check. And these are all the checked exception. And then this now we have to see the chained exception only. No, ma? Am I correct or not? Okay. Chained throws keyword. We have seen the throws keyword. Here. So I forgot to tell you. This throws keyword. So here in this function, I am telling throws null pointer exception. That means this method in function prototype. In function prototype also, in function prototype, not a function prototype actually here. Actually, this function throws a null pointer exception. Here, what I am giving an instruction to user means this function throw null pointer exception. So those who are calling this function throw method, you have to handle. So while I am calling that method, that should be within try catch block. Okay, and then next. chained exception. So what is a chained exception? For arithmetic exception, for example, for arithmetic exception, what example for arithmetic exception is a divide by 0. So for a divide by 0, if I am giving input is wrong, so that's why I'm getting a divide by 0 error. No? But the actual cause of the arithmetic exception is IO exception. Actual cause of that arithmetic exception is IO exception. So I can combine one exception with another exception. So this is called a chained exception. Okay, so chained exception was added in Java JDK 1.4. So this features allow you to relate one exception with another exception. That is, one exception describes cause of another exception. For example, arithmetic exception, divide by 0. So divide by 0, when we will get this type of exception means, if I am giving input is wrong, so that time only I will get this arithmetic exception, divide by 0. No? So this actual cause of this exception is IO error. So the method will throw only, but this method will throw arithmetic exception. This method won't throw IO exception to the caller. So the caller does not know about the actual cause of exception. Actually, the caller does not know about the actual cause of exception because it is throw only arithmetic exception to the caller. So the chained exception is used in such type of situations, allow you to associate another exception with an exception. The second exception describes the cause of the first exception. Second exception describes the cause of the first exception. So for that, in Java at JDK 1.4, they have introduced two constructor and two methods. Okay, so for this chained exception in Java JDK 1.4, they have introduced two constructor and two methods. The two constructors are one constructor with the throwable object, another constructor with the string and the throwable object. Okay, so this parameter can't specify the actual cause of exception. So when we will see example, that time only it will get clear. So now these two constructors are introduced in JDK 1.4 under the method get cause and init cause. Two methods are also introduced. So this method get cause method returns the actual cause associated with the current exception. So init cause set an underlying cause with the invoking exception. So we will see one example. Now here, that is main function. So here is the main function. Here is the main function. So in main function, I am calling the function divide 5, 0. So then control will come to this definition, divide 5. So here for A value is 5 and B value is 0. So A value is 5 and B value is 0. So here I am checking if B value is equal to 0 means what type of exception I have to throw. I have to throw that arithmetic exception. So here arithmetic exception, and here I am passing the top layer as the argument. And then in JDK 1.4, two methods are introduced, get cause and init cause. So here I have used init cause. So this is an object, arithmetic exception object. AE is the arithmetic exception object. So I am calling init cause method by using this AE object. So by using this function, what I am telling for this arithmetic exception, that actual causes IO exception. So what I am initializing for this arithmetic exception, this actual causes IO exception. So now I am after initializing this string, after initializing this exception, I am going to throw that object AE. I am going to throw that object AE. So then it will come to this catch block, and now it will print caught AE. Actually, caught AE. So AE is the java.lang arithmetic exception, and then here what string we have passed the top layer, so that will be printed here. And then another method get cause. So by using the get cause by using the get cause method, I'm going to get the actual cause of this exception. So actual cause of this exception is here I have printed actual cause. Actually here is a small letter, actual cause colon java.io exception, and then here while I'm creating object, what string I have passed cause. Okay, Mama, understood, Mama? So here so now understood about this method, how one exception is associated with another exception, how we have to associate one exception with another exception. That you understood about chained exception. Say sir, no ma?
Ma'am, in the output, why it is using java.io exception? I didn't have it.
So this get cause, no ma? So in this init cause for this arithmetic exception, what I have initialized, I have initialized a new IO exception, no ma? So for this IO exception is available in the package java.io, ma. So while I am printing AE.getCause, it will print the whole thing, ma. That is a java.io. IO is the package. In that package only that IO exception is available. So java.io exception colon, and while I am initialized, here I have passed the string cast, no? So that is also will be printed here, ma. Understood, Amma? Actually here this actual is small, A is small. Understood, Amma? Say yes or no, pa?
Yes, ma'am.
Okay. And then From JDK 7, they have introduced 3 new concepts in exception. They have introduced 3 new concepts in exception. The first one is expanded form of this try statement called try with the resource. Okay, so first one is expanded form of this try statement, that is try with the resource. So we will see this will in IO. Okay, so still we didn't see that IO, how to get input and how to get an input, a file input. So IO. So we will see one separate topic IO. So in the topic we will see about this exception, try with the resource. Okay, so try with the resource. And second feature is called multi-catch. So second feature is called multi-catch. In the previous example, the single catch block can catch only one type of exception. No? One catch block can catch arithmetic exception. One catch block can catch null pointer exception. So like that. But the single catch block cannot catch more than one type. No? But you can use exception class. Generally, you can use exception, but single catch block cannot catch arithmetic exception and also null pointer exception. So that is not possible up to before JDK 7. From JDK 7, the single catch block can catch more than one type of exception. So that is a multi-catch. So that is multi-catch. And then third is sometimes referred to as a final rethrow or more precise rethrow. Okay, we will see that one later. So this first one we will see in IO. Okay, so in IO concept we will see that first try with resource, and multi-catch features allow 2 or more exceptions to be caught by the same catch class. Okay, so to use a multi-catch, separate each exception type in a catch block with the OR operator. So how you have to separate that exception means by using OR operator you can separate the exceptions. So by using that, the single catch block can catch more than one type of exception. So here each multi-catch parameter is implicitly final. So because each multi-catch parameter is implicitly final, it cannot be assigned a new value. Okay, so we will see this more precise rethrow features restrict the type of exception that can be rethrown to only those checked exceptions that the associated try block throws that are not handled by the preceding catch class. Okay, we will see that by using example. Now we will see the multi-catch. Okay, so in that multi-catch, here catch block. No? So in this catch block is going to catch arithmetic exception. It is also going to catch array index out of bound exception. So the single catch block can catch arithmetic exception and also array index out of bound exception. So like this single catch block can catch more than one by separating the exception by using this OR operator. By separating all the exception by using OR operator. So like you can use more than I can also add one more exception by using one more OR operator. Okay, so this is called multi-exception. Okay, so when divide by 0 exception is occurred, so when I print this object, what it will print? Java.lang.arithmetic exception divide by 0 error will be occurred. Okay, so if array index out of bound exception is occurred, so then it will print the array index out of bound exception. Okay, understood? Multi-catch? Multi-catch understood? Say yes or no? Say yes or no, multi-catch you understood or not?
Yes, ma'am.
Okay. Thank you. And then next, final rethrow or more precise rethrow. So this first one is compiled by using JDK 1.6 and second one is compiled by using JDK 1.8. The same program, while I'm compiled by using a JDK 1.6, I'm getting an error. But the same program, while I'm execute this by using a JDK 1.8, this program is compiled and executed successfully. So, I will explain this one. Here from main function, I'm calling add. I'm calling the function add. So control will come to here. Okay, and then this function throw. So what type of exception? IO exception. And then here throw new IO exception. So this is catched by which type of object? This is catched by exception object. Okay, so this is catched by exception object. Here I am throwing what type of object? I'm rethrowing the same key. But what is the type of exception? But here catch block, in catch block I try to catch by using which which class object? IO exception. So this type of program, while I'm compiling in JDK 1.6, I will get an error because precise exception Java 11 unreported exception. So java.lang.exception must be caught or declared to be. So here, if I return exception IE means then I won't get error. So here, if I have written exception IE means I won't get error. But IO, actually here it is throwing IO exception object only, but it is catched by which type of reference? Exception reference. So here I'm rethrowing again that exception reference, but here I try to catch by using IO exception object. I will get an error. I will get an error. Yes, I will get an error. But in JDK 1.8, so when I'm execute this program by using a JDK 1.8, so it won't show any error. So first, so here it will print the E. So E means what it will print? The java.io.io exception. So here actually here exception type, but actually what exception is thrown here, that is IO exception. So that's why here java.io.io exception. And then here I am rethrowing, so that will come to here. So then it will print hi java.io.io exception. Then after that it will print this statement hello. Understood? So in JDK 1.6 it is not allowed, but after from JDK 1.7 this is also allowed. Understood? Say yes or no? So, okay, the Java SE7 compiler allows you to specify the exception type. For example, IO exception in the throws class in the rethrow exception method declaration, because you can rethrow an exception that is a super type of any of the types declared in the throws. In release prior to Java SE7, you cannot throw an exception that is the super type of one of the catch clause exception parameters. So a compiler from a release prior to Java SE7 generates the error unreported exception must be caught or declared to be thrown at the statement throw E. So the compiler checks if the type of the exception thrown is assigned to any of the types declared in the throws class of the rethrow exception method declaration. However, the type of the catch parameter E is exception, which is a super type, not a subtype of IO exception. Understood, Amma? Understood, Anapa?
No, ma'am.
Okay. So one more time, here one more example. Arithmetic exception, and then here exception type. Okay.
How the compiler will know that is that type of exception, ma'am?
Here actually what type of here I am throwing this example. See here, here what type of exception I am throwing here? I am throwing arithmetic exception. Here I am throwing arithmetic exception. So arithmetic exception object. Here what is the reference type? Exception. Here exception. So when I am EX, when I am rethrowing this EX, when I am rethrowing this EX, here it must be exception. I cannot write arithmetic exception before JDK 1.7. But if I return here arithmetic in this example, I will explain this example one more time, then you will get clear.
Okay, ma'am.
Now add function. From main function, I am calling the add. I'm calling the add. So control will come to here. Okay, and then here what type of exception I am throwing? I am throwing arithmetic exception object. Actually here I am throwing arithmetic exception object. This is catched by the catch block exception. So if I return exception means, then that can catch all type of exception. Actually here it is an arithmetic exception, but what is the reference type? That is super class reference. Exception is the super class to all the type of exception. So here the reference is EX, but here if I am throwing EX, but there is no exception class in that catch block, the compiler itself, it will check, it is checked that one, and then it will show the error immediately. But here I am throwing exception reference, but here what I am having an arithmetic exception, IO exception, two catch block, that is arithmetic exception and IO exception. But here this reference is what type of reference? Super class reference. So super class reference means here the catch block must be with the exception class. Okay, so other in JDK 1.6, otherwise I will get compile time error. So compiler itself will identify, and it will actually here what type of object we are rethrowing. Here we are rethrowing. In the catch block, the compiler easily it can find out, because in the catch block we are mentioning. So in the catch block, a compiler was compiling the statement, that time itself it will check the type of the reference. Here the type of the reference is exception, but here in all arithmetic exception and IO exception, there is no catch block with exception class. So compiler can be identified and it can show the error bar. But at the JDK 1.6 ma. So, but after JDK 1.6 here actually the reference type is exception, but it contains what type of exception? Arithmetic exception. No? So now it will go to which catch block means it will go to that arithmetic exception catch block, and then it will print hi java.lang.arithmetic exception. So first it will print first for this EX it will print java.lang.arithmetic exception. So after rethrowing this one, it will print a hi java.lang.arithmetic exception, and then it will print the statement hello. Understood, Appa? Understood, Anatma. Actually, now I have a JDK 1. I don't have JDK 1.6 compiler. Otherwise, I will show you the demo of this program. Got it, Anatma? Say, Mama. So, okay, so in the next class, I will install JDK 1.6 also, and then I will try to explain. I will execute this program, both programs. In JDK 1.6, I will execute in both JDK 1.6 and also in JDK 1.8. After installing that, I will show you. So then you will get clear idea about this topic. Now you understood somewhat or not, pa? Say yes or no, ma'am?
Yes, ma'am.
Okay, pa. So next, creating our own exception, ma. So creating our own exception. So for that, here we have a two class, ma, exception class and throwable class. So to create our own exception type, we have to create one class. So that class should be the subclass of exception. So to create our own exception, so we have to define one class. So that class should be a subclass of exception. Okay, so which is of course a subclass of a throwable. So throwable is the superclass for all the exception. So exception define 4 public constructor. Actually, in exception class, 4 constructors are there. So 2 constructors are already we have seen 2 constructor. No, the 2 constructors are used in chained exception. The other 2 are here. So exception without argument and exception with one string argument. That other 2 are exception with the throwable instance, and another one is exception string comma throwable instance. Okay, so totally 4 constructors are there in exception class. Okay, so here this is my own exception. This is my own exception. This is my own exception. So what is the name of this exception means my exception 1. So if you create any exception, if you create your own exception, that exception should be the subclass of exception class, exception class or throwable class. Okay, so that should be subclass of. So that's why here extends exception. So now this my exception 1 is the subclass of exception, and then here I have created object for my exception 1. So here I am throwing obj. So this obj in the previous example, we have thrown arithmetic exception object. We have thrown array index out of bound exception object. So here one object is thrown by using the keyword throw, but this object type is my exception 1. This is created by ourselves. So this is created by ourselves. So now this is catched by the same type of my exception 1. So now when I print this, what it will print? It will print my exception 1, because here there is no any constructor, no, so just it will print my exception 1. When I print this object, it will print my exception 1. Next, here we will see example. This my exception 1 have 2 constructor. One is no argument constructor, another one is with the string constructor. So here 2 constructor for here 2 constructors are used to create our own exception. No, one is exception, another one is exception with the string. So now, so here this is no argument, and then this is with the string. So from here, what I am calling my super str means this already we have here about this keyword super. So have you heard about this keyword super or not? Say yes or no? So this the super is used to all the base class members. So this will call the base class one argument constructor. So who is the base class for this my exception 1 means exception. Okay, so that exception class have one string. That string is initialized by this string. So here when I am creating object for this my exception 1, I am passing the string. It's my own exception. So now so this is the string is passed to that super class exception. So when here I am throwing that object obj, so that is catched by this catch block. So now when I am print this e bar, so what it will print? It will print my exception 1.1 colon in the previous one. So here there is no constructor and I'm not initialize any string. So that's why it is when I'm printing this object, when I'm printing just an object bar, it will call the toString method of that super class bar. Actually one method is there, toString. So that toString method will, when I'm printing object, it will call the toString method. That toString method will return one string. That string only is going to be printed here. So now the toString method, what it will print, what that will return means that will return my exception one. So that's why it is printed that one. But here I'm while I'm creating object, what I have passed it's my own exception. No? So when it call the base class constructor, that class string is initialized with my exception one colon and it's my own exception. So when I am returning, when I'm printing that object, the toString method is called. The toString method will return that corresponding string. So that string is nothing but my exception one colon. It's my own exception. In the previous example, it is just printing my exception one. In the next example, what string I am passing, that is also printed along with that exception name, my exception one colon. It's my own exception. And then next, here I have override the method. I have overridden the method toString. Okay, I have overridden the method toString. So when I'm here, I have created the object. So it's my own exception I'm passing. So now this strs, it's my own exception. So now actually the base class string is initialized with it's my own exception. But when I am printing this object eBar, instead of calling the base class toString method, this overridden method is invoked. So this overridden method is invoked. So when I'm printing this object, what it will print? It will print from my own toString. That will be printed. In the previous example, and now my exception one colon. Then only that what string I'm passing, that is printed. But if I have overridden, that string only be invoked, and that's this toString method only invoked, and this method is this string is returned, and that is going to be printed here. Understood, Abba? Say sir, Papa. Understood, Anatma?
No, ma'am.
No. Okay. One more time I will repeat, Abba. Here I have created my own exception. So if you are creating any exception by your own, that class should be extends from exception class or from throwable class. Okay, so the new exception, that must be the subclass of exception. Okay, so here there is no constructor. Nothing I have written within this class. Okay, and then from main function, I try to create an object for this my exception one. So this is an exception class. This is an exception class. This exception is created by our own. Okay, so here I am throwing that obj object. So here I am throwing one exception. What is the type of that exception? The type of exception is my exception one. So this is created by ourselves. Okay, and that is catched by the catch block. So here also I have used the same my exception one. Here I am printing the object. So whenever you are printing object, so this is normally can you print in C++? Can you write a cout obj? Can you print directly that obj is possible in C++? Anyone say?
No, ma'am.
That is possible. When it is possible means we have to write a overloading operator overloading function. Have you remembered that, that insertion extraction operator overloading function? So then only it is possible in C++. Like here, in Java, if I directly print the object, so what it will do in superclass, one for all the classes, one superclass is there, no object. So like for all class, one superclass is there. In that superclass, one toString method is there. Okay, one toString method is there. So when I am printing object, it will call the toString method of the base class. So that toString method will return one string. So that is going to printed. So okay, so how that toString method, that string is initialized means when I am creating object, when I am creating object, so that time, so that string is initialized by the name of the class name, class name. Okay, so here when I am printing E, so what it will call the toString method of the base class. Okay, so that toString method will return one string. So that string is nothing but the name of the class name. So name of the class name is what? My exception one. Understood? This one you understood? So that's why here I am getting my exception one. Understood? So now I in this class I have written toString. Two constructor. So in this class, I have written two constructor. Two constructor is there for creating our own exception. One is exception without argument, another one is exception with a string argument. So here I have created two constructor. One is without argument. So this will call the base class no argument constructor. Who is the base class? My exception. So this will call from here it will call the base class no argument constructor. And then here this is from here I'm explicitly calling the base class one argument constructor. One argument constructor, and that one argument is also string type. Okay, so here I have defined two constructor. So you leave it. So now come to main function. So in main function I'm creating object for my exception one. So this my exception one is created by ourselves. So that is a subclass of exception. So now I'm throwing obj. So here I am when object is created, it will call the constructor layer. So here I'm creating object for my exception one. It will call the constructor. So now this str is initialized as it's my own exception. And now the toString method. So this will the toString method str. toString method return is going to return one string. No, so that string is initialized as this class name my exception one. And then here I have passed to one string. No, it's my own exception. So now that string is initialized with the class name my exception one, and then colon, and here what string I am passing. So that is concatenated with that name my exception one colon, and it's my own exception. Okay, so when I am calling the super str, then I am calling the super str, what will happen? The base class have one string. No, if there is no constructor, parameterized constructor means that string is only initialized with the my exception one. That base class string is only initialized with the my exception one. But here I have created one parameterized constructor. From this parameterized constructor, I'm calling super str means now that string, base class string is initialized with the name of the class name, my exception one colon, and along with that, this it's my own exception. That is concatenated with that string. Okay, so when I am printing, here I'm throwing that object obj. No, so here that is catched by the my exception one object. So when I am printing this e, so now it will print my exception one colon along with the string what I'm passing while I'm creating that object. So it's my own exception. That is also printed. Understood? Say yes or no, ma?
That colon is inbuilt, ma'am?
Yes, yes. Automatically, the colon is also concatenated, ma. We don't need to give any colon. Ma. Automatically, it will print. Got it, ma?
Ma'am, if we do not write no argument constructor here, will there be any changes, ma'am?
It will only print my exception one. If there is no parameterized constructor.
No argument constructor, ma'am, not parameter.
No argument constructor means, so what will happen? Here no problem. It won't make any problem because here I'm creating object with the parameter. No, but if I am creating object without the parameter, that time I will get a problem. Sometimes if I am throwing only my exception one object, new my exception one, sometimes somewhere this is created by ourselves. No, so now somewhere I want to throw the exception my exception one. So that time I'm creating object without a parameter. That time I will get an error. No, understood? I cannot object without parameter. So that's why for safer side I have written. Other than that, this program won't show any error. In this program, it won't show any error.
Okay, ma'am.
Got it. So this thing you understood? So whenever you are printing that object, so here and all, here also java.io.io exception. When I'm printing this e, how I am getting this java.io.io exception means that super class. When I'm printing this e, the toString method. So the toString method will return that java.io.io exception string. So that is only printed here. Understood? How when I'm printing e, how I'm getting the string java.io.io exception means, so here what type of exception I'm throwing io exception. No, so this will call the constructor. So that constructor, when I'm creating object, it will call the constructor. So when it calls the constructor, that time itself, that string is initialized with this io exception. So io exception is nothing but java.lang.io exception. So when I'm printing that e, so that string will be printed. That string will be returned by the method is toString. So got it, Appa? Got it or not, ma? Say yes or no, pa? Say yes or no, ma? Yes means yes, no means no. Tell me, pa? Yeah? Okay. So one more example. So here, I have overridden. Up to this you understood, Lema. So now I have overridden this method toString. So here to constructor, and I have overridden this toString method. So now in this toString method, what I have written from my own toString. Okay, so here I'm creating an object. So this will initialize. This will call the base class constructor. So here it will call the base class constructor. So now that will initialize the string as my exception one colon. It's my own exception. When I create an object, it will come to here, and then it will call the base class constructor. In the base class constructor, the string is initialized as my exception one colon. It's my own exception. And then now here I am throwing that object, and then that is captured by this catch block. When I am printing this e, instead of calling the base class toString method, here the toString method is overridden. So if it is overridden, the same class toString method is only invoked. If it is called the base class toString method, when I am printing this object, what it will print? It will print my exception one colon. It's my own exception is printed. But here I have overridden the toString method. This toString method will return what type of string from my own toString. So when I'm printing this E, what I will get from my own toString. Got it, Appa? Got it or not? Ma? Say yes or no, Pa?
Yes, ma'am.
Okay, thank you. Uh, this is also one example for own exception creation. So here I have created my own exception. So if you are creating any exception by your own, so that must be the subclass of exception class or throwable class. So that's why this is extends from exception. Okay, so here I have one private data member. So within this class, my exception class, I have one private data member. So I cannot access this private data member from outside. Okay, and then here I have one parameterized constructor. This is the parameterized constructor. Okay, and then toString method. I have overridden the toString method. Okay, and then here exception demo class, another class called exception demo class. Here this class is over. So here the classes get over. My exception classes get over. So this is the toString method. Here in exception demo main function. I have written the main function within the class exception demo. So from main function, I am calling the method compute. Okay, so here I have method compute. So for compute, I am passing argument 1. Okay, so this method throw what type of exception? This method throws my exception. This method throws my exception. Okay, so here I am passing A as the 1 layer. So first it will print called compute, and then that you got the value A value 1. So it will first time it will print called compute 1, and then it will check A value is greater than 10. No, A value is not greater than 10 because A value is 1. So then it will print normal exit. So then it will print normal exit. So after that, control will come to here. After the control will come to here. So again I'm calling the compute method. So now what is the value of A? 20. So now what it will print called compute 20, and then I'm checking A value is greater than 10. Yes, A value is greater than 10 because now A value is 20. So if A value is greater than 10, what I'm throwing here, I'm throwing our own exception. That exception is my exception. So here I am throwing our own exception. That exception is my exception. So here A. So this A is nothing but 20. No? So that will when here I'm creating an object. So that will initialize the this private data member. This private data member detail as 20. So now this private data member of this my exception classes, when exception is occurred, and when I'm throwing this exception, I'm initializing the private data member of the my exception class, private data member detail as 20. Okay, so after that, it will after that it will here I'm throwing, no, so that is catched by this catch block. So here I'm throwing, that is catched by this catch block, and then I'm printing caught E. So here E. So E now this will call toString method, but the toString method is overridden here itself. So now this will call this toString method. So in this toString method, what I'm returning my exception, and then square bracket, and then detail. The detail value is what? 20. So here first it will print caught. So when I'm printing this E, so this will call this toString method. In this toString method, what we are returning my exception within square bracket, we are returning the value 20. So, so now caught my exception 20, that will be printed. So the toString method actually where it is defined, it is defined by throwable and inherited by exception. So if you are not overridden, which class toString method is invoked, that is exception class toString method is invoked. Okay, so the exception class toString method is invoked. If you are overridden the toString method, then your own class toString method is invoked. So first it display if the base class toString method means exception colon, and then that string is printed. So first you display the name of the exception followed by a colon, which is then followed by your description. Okay, by overriding toString, you can prevent the exception name and colon from being displayed. Understood, Appa? Say yes or no? Say yes or no? Appa? Understood or not, ma?
Yes, ma'am.
So when you will get clear about this exception handling and all means, if I give some program for exception handling and you doing by yourself, then you will get the clear idea about exception handling. And still you have some more confusion with the chained exception, not chained exception. What are the more precise exception? JDK 1.6 and JDK 1.8, how it is vary. So that I will install JDK 1.6 and I will explain and I execute that program, single program in both the compiler. Then you will get clear idea. And that time I will explain very clearly about the concept. Other than that, any doubt in the remaining topics, ma? Other than that, any other doubts, pa? The remaining topics? So that's all my exception handling. What, pa? I thought you are all a little bit confusion with this exception handling topic, I thought. So I will give you more program to practice. Okay, so you do by yourself. Then only you will get clear idea. Okay. So nothing in this the exception handling. Only the try keyword, try, catch, finally, throw, throws, and then checked exception, unchecked exception. And then if we are handling that exception by using catch block, finally means the program is terminated normally. If the exception is handled by JVM, the program is terminated abnormally. And then nested try within another try block, and then throw manually. You can throws means you are giving an instruction to user this function definition and all may throw this type of exception. You have to handle while you call the function. And then a chained exception. So you can associate one exception with another exception by using a method init cost, and then by using get cost method you can get the actual cost of that exception. And then three new features added in JDK 1.7. One is a try with resource, so that we will see in IO class, and another one is a multi-catch that we will see. Multi-catch is the single catch block can catch more than one type of exception by separating or operator. Okay, and then more precise. So you are all have doubt in this more precise. So I will explain one more time. More precise. I will explain one more time by using JDK 1.6 compiler. And then next, creating by your own exception. So for that, that class must be the subclass of exception class or throwable class. And then you can overriden the toString method. If you are overridden the toString method, you can avoid that class name and then colon, and only the string what is returned by the toString method that will be printed. So that's all. Other than that, in this exception handling, nothing is there. Okay, so hereafter you have to do more programs. Then only you will get practice in exception handling. I will give you the program. Okay, any doubt about other than